I've got a little network right here in front of me. Now, if you take a look at this network, first of all, I got 1, 2, 3, 4 computers on this network, and they're all plugged together into this switch in the center, but I also have a router. Now, this router also has an IP address because routers always have an IP address that's part of one local area network, but it also has another IP address, which I don't have on here right now, that helps it go out into the big internet. Now, here's the issue. Now, we know about ARP from the previous episode, but the challenge we have is, how do we ARP? For example, if this computer right here wants to talk to this computer right here, he would normally just broadcast out an ARP, get the IP address, and everything would be great. However, what if this computer right here wants to talk to somebody way out on the internet? In that case, he's still going to have to ARP, but he's going to have to ARP to get to his default gateway, to his router. So what we need is something built into every network that identifies it as its own local area network, and also a mechanism that allows an individual computer to determine, hey, if I'm talking to this IP address, this is a local call, just go ahead and ARP. However, if it's a long distance call, go ahead and talk through your default gateway, through your router to get out to the internet. And that's where your subnet mask really comes into play. Now, to help get us all wrapped around on this concept, I've got something laid out right here I'd like you to take a look at. Now, what we're looking at down here is what we're going to call my network ID. The network ID is the part of the network numbering system that has to be identical for every computer on this particular network. Now, on my network, which I've decided to set up this way, all the computers are going to be 232.25.208, and then here I put 0. The idea behind this is that when I'm setting up these network IDs, no computer can have just a 0 as part of its numbering system because it's reserved for what we call the network ID. So I could have a computer in this network ID that's called 232.25.208.14, but no computer could be called 232.25.208.0. That's reserved for this network ID. Now, the part over here that changes for every individual computer is going to be called the host ID. So what I'm going to do is I'm going to put a little skewer here to kind of separate it, and that's where this guy called the subnet mask comes into play. A subnet mask is a string of 1s followed by a certain number of 0s. Everywhere there is a 1, the numbers have to stay the same. Anywhere there's a 0, you can change the values. So in this particular case, our subnet mask is going to be 255.255.255.0. Now I need to warn you about something for a minute. Always remember, computers don't use the dotted decimal notation. It's just for us human beings. When we type in 255.255.255.0 into our computers, he instantaneously changes it into what it really is, 24 1s followed by 8 zeros. So let's take a look at this example one more time. Now, in this particular example, the way we've got it set up is that the first 3 numbers are identical, and then the last number can be anywhere from 1 to 254. We can't use 0 and we can't use 255. But watch this. So what I've done here is I've replaced the third set of 1s with all 0s. So let me go ahead and get the right value in there. And what we now have is a subnet mask of 255.255.0.0. Now, as you're looking at this stuff, there's one thing you need to keep in mind. We always use these terms 255s and 0s, but we know that the computer just uses all 1s and 0s. So what we can do is we can simply, instead of saying 255.255.255.0 or 255.255.0.0, we can talk like the cool kids and simply count the number of 1s. So taking a look at this, we'll see we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So what is commonly done is then we simply say this is a WAC 16 subnet. That little slash is what I call a WAC, and that is common terminology, so you want to get used to it. The cool part now is that when we change the subnet mask to something like this, we could literally, if we wanted to, say only the first 2 numbers have to be the same. You can use any other 2 numbers that you want to use. It doesn't matter because they're all going to work. So with a WAC 16 subnet, that means only the first two digits have to be the same for all the computers. So our network ID could be anything from, I guess, 232.25.1.1 to 232.25.255.254. I mean, think how many different computers we could have on this little tiny network. So usually the subnet mask gets smaller for really huge networks, and it gets longer, like a WAC24 255.255.255.0 for smaller networks. In fact, we know these things ahead of time. For example, if we use a WAC24 subnet mask, remember 255.255.255.0, we get exactly 254 hosts. So that means the smallest network, at least based on what we know so far, we could make would have up to 254 hosts in it. Remember, you can't use 0 or 255, okay? So this really makes things a big deal when it comes to making these subnets right at what we call the dots, where it's only 255s and zeros. We've got other episodes coming up where we're going to make it a little bit more interesting. So basically, in order to make our network work, all of the computers within this one broadcast domain, within this one network ID, are all going to have the same subnet mask, and wherever there's a 255 in the subnet mask, they're going to have the exact numbers. Now, this gets put into every computer in existence. So what I want to do right now is take a moment and walk you through a Mac, a Windows system, and a Linux box to see where these numbers exist on your computer. Here's an example of network settings on a modern Mac system. You'll see that we have an IP address, a subnet mask, and what they call the router is the default gateway. Now, taking a look at Windows, here you can see again, now you got to dig a little bit to find it, but I have an IPv4 address as they call it, and then I see my subnet mask, and if we look down a little bit more, you can actually see where it says default gateway. Last is Linux. With a Linux system, you'll see that we have an IP address, we have a subnet mask, and what they call the default route is the default gateway. Now that we've got these values punched into our operating system, let's put all of this to work. Now, in this particular example, I've got all of these computers, and what they're on is a network ID of 232.25.208 with a WAC24 or 255.255.255.0 subnet. Now, let's say this computer right here wants to talk to, I don't know, 232.25.208.14. Got it. So what he'll do is work with the subnet mask to determine whether this is a local call or if he needs to send it out to the default gateway. Now, I've changed the board here a little bit. Let's watch this in action. So what we have here is, this is my local computer. He's going to be 232.25.208.22 in this case. So the subnet mask here is going to be 255.255.255.0, or for us cool kids, a WAC24. Remember, it's 24 ones followed by 8 zeros. Now in this one particular example, he wants to talk to a computer with the IP address of 232.25.208.9. Yeah, I know I said 14. Let's make it 9 instead. The subnet mask allows my local computer to take a look at the address that he's going to and determine if it's a local call or a long-distance call. So with the subnet mask, anywhere there's a 1, the numbers have to be the same. Anywhere there's a 0, they can be different. So in this particular case, comparing my IP address to who I want to talk to, the first 3 values, the first 3 octets, are the same as mine. Therefore, I know that it's a local call. And since it's a local call, all I need to do is ARP out onto the network, get the MAC address of whoever I want to talk to, and off it goes. So that's easy. Now what happens when it's not within my network ID? Okay, so once again, this row right here is my local computer, 232.25.208.22. This time he wants to talk to a computer at 232.52.208.9. So I want you to look at this very, very closely because it looks very similar to the previous example, but look at the difference right here. The big difference is that we have changed one of the values on the left-hand side, on the network ID side. Now, I could have put a big, complicated, much different number in there, but that would have been too easy for you. It's just like if you're dialing somebody and you accidentally transpose two numbers and you end up calling somebody in a faraway place. Well, the exact same thing happens here when it comes to IP addresses. So let's look and let's run through the system and let's use the subnet mask and determine, is this a local or a long-distance call? Here we go. So we take a look at the subnet mask. Remember, anything where there's a 1, the numbers have to be identical. Anywhere on this side, they could be different. So as we compare these two numbers, 232, they're the same. But look right here. This is 25 and this is 52. The numbers are different. Instantaneously, we know that this address right here is not a part of our local area network. We're going to have to send all of this information out through the default gateway because it ain't local. Now, the thing you need to remember about all this is that we're really not changing the IP packet part. We're not changing the IP addresses. All we're doing is we're telling the individual host who to ARP for. If it's not a local call, it needs to ARP to the default gateway, and it knows the default gateway's IP address because you typed it in when you set the system up, and that's why we have to type in the default gateway. That is your router, and that's where all this information comes from. So when you're working with computers, the most important thing to remember is, number one, you're going to have an IP address. Number two, you're going to have a subnet mask. And number three, you're going to have a default gateway, because all of these guys work together to make sure your data goes where it needs to go. Thanks, Subnet Mask.